Okay. Okay. Good morning. So we'll start our lecture. We'll keep talking about the camera model. Okay. Today I'll try to finish the camera model. Okay, so last time we talked a little bit about intrinsic extrinsic parameters, and today I'll try to finish the homogeneous matrix. Also talk about affine transform, perspective transform, and what's the camera model for, and what's the camera calibration for? Is for between the relationship between 2D and 3D. So we'll continue. So basically, when we use the camera, so we have a 3D camera coordinate or 3D camera model here. And suppose we have an object, we observe an object. If it only has one object, we will say this object here, we define this object will be the world coordinate. If you have a two object, more than one object, two or three objects, you should define one object to be the world coordinate. Or sometimes we call it a reference. This will be your reference coordinate. Okay. So between in the world or in the scene, okay, between object or between the object and the camera, okay, that means 3D to 3D coordinate. We will exist the rotation matrix here and translation matrix. So two 3D coordinate, the relationship is rotation and then translation. So what's the plus mean? This is plus. Plus meaning it can be separate. It can be individual. So that's meaning you can do translation first and then do rotation. Or you can do rotation first and do translation. So this event or this turn and this turn, both turn are independent. 相加就两个是独立的意思，这很重要。So this is assume the capital X, Y, Z is 3D coordinate world, and this is a camera coordinate. So we have translation, we have a rotation. So both we call extrinsic parameters. Between the 3D camera coordinate and we project to the 2D coordinate. This one we call projection. Projection matrix also called intrinsic parameters. 内部参数. So that's 3D and project to 2D. And what's the lambda? Lambda is kind of a scaling term. We call scaling term. Scaling term is a constant. Okay. And constant is meaning what? Meaning suppose if you scaling term lambda is equal to 1. Okay. That's UV1. If lambda is bigger, that's meaning you will zoom. But actually, if this is a bigger, like a 3 or 2, a 3, 4, 5, that's mean you will scaling will be zoomed in more, bigger. Okay. So that's scaling term. And the other important one is the optical axis here. Optical axis is the axis of the z of camera coordinate, and optical axis will intercept with the image coordinate, and this one will be we call principal points. And principal points is not the middle point, but it will be the center point. Center doesn't mean the middle, it will be center point of this image. So we define the intrinsic parameters has a scaling factor related to the focal length, 跟焦距有关. So it is FF. So if the aspect ratio is like this one, like this one. Sorry. Like aspect ratio is, I mean, if 1 to 1, it means it's a square. Euler is 1 to 1. That's meaning your cell of sensor is 1 to 1， 是1比1的比例通常。那如果是 suppose 1.2 to 1， 就是 1.2 比1的话，那你就是一个宽一个比较宽一个比较窄这样子，那就会变形，拍出来就会变形。So Euler this is almost 1 to 1. So if you ignore this one, this will alpha beta will become FF. So focal length is the most important factor from your camera coordinate project to the image coordinate, 2D image coordinate. In the other word, if you try to reconstruct from 2D to 3D, actually it's from this one, 2D, this is 3D project to 2D. This is from here is you have a 2D, you can reconstruct to 3D. But the most important one is the focal length. So focal length is the most important one for the relationship between 2D and 3D. And gamma right now is gamma here skew factor. Skew is like a this is skew. 有点歪掉了. But right now, skew factor is equal to 0 because right now the high technology, I mean, it will not that it happen. Okay, so we can ignore the gamma. And U0 and V0, this one, principal point is this point. The Z axis, also optical axis, the intersection between image coordinate and optical axis. So this is a real image center. But image center doesn't mean the middle point of the image. Okay. So need to calibrate. So if we try to, the purpose for the camera calibration is try to solve the extrinsic parameters and intrinsic parameters. 就我们讲 next lecture we will talk about camera calibration. And camera calibration, the purpose is try to solve. We have 5 intrinsic parameters. We have 12 extrinsic parameters. And this is a Rx, the exo 旋转, Ry, Rz, and 3 translations, Tx, Ty, Tz. Okay. So this one is meaning from world coordinate. We transfer to the image, camera coordinate here. From camera coordinate, we project to the image coordinate. In other words, this is image coordinate. We reconstruct to camera coordinate, become 3D object. And from camera coordinate, okay, we recover to the world coordinate. So between two, what's different between two? Is meaning when you from here, you reconstruct to here without rotation and translation. So that's meaning your object is here. So that's meaning if you object from 2D to 3D, will become this one. But back to the world, you will become rotate. And put the image on the location, the exact location， 就是你会把物体放在正确的位置，不然你会像那个 OpenGL 一样，你只是看到物体在这边，你还是不晓得物体的正确位置，只有物体在这边，你要把物体。So that when you do the movie, when you do the AR, okay, for the movie and AR, the important one is that after you reconstruct here, you reconstruct to the object here， 你已经把物体做出来了。物体是在这里，那是 AR 东西。那你要把物体跟那个场景的 scene 要融合在一起的话，你就要把场景的这些 R 跟 T， 你要把物体就一个虚拟物体在这里，那背面都没东西嘛。那你当把这个物体要融合跟实际的 AR， 宝可梦要跟 AR 融合到，你要把这个物体放到实际的位置，那这时候就要。这个时候你要去设计，或是要去看它放在哪个位置，然后做什么旋转这样子。那 the homework will teach you how to do the AR。OK， 那我在这里有个 demo， 先给你看一下。So here's plane, right? So you have plane. The important thing for AR, you need to find the plane. 你要给它一个地，那个地就是你摄影机的那个，这把东西放。This is the object, right? So the object you want to put it to somewhere. So in this case, you want to put. Sorry. Okay, this is the object. So the object, you create the object, or you take a photo and recover to the 3D. So the object is here. Okay. But for the object, so here is the camera coordinate. But you want to put the object in the real world. So I want to put the object attached to this plane. That's meaning I need to detect this plane. So this plane will be the X and Z plane. See that this plane will be, you attach it to here. So this plane will be X and the Z plane. Right? The XZ, so Y is here. So you want to attach this object to this plane. So you need to detect the plane center. 你要先把这个物体，你要放的这物体的中心点找到，然后把你要 AR 的东西把它放到这个 plane 的这个中心点，这样子。So XY 嘛 ，XZ 嘛，然后 Y 在这边，那就跟着它这样走。那你摄影机不动 ，camera doesn't move, but object move. That's meaning your motion is R and T. So you control or you detect the plane corresponding to the camera. So you have plane here, and this plane corresponding to camera, you have rotation and translation. And you attach to the object here, and you know the rotation and translation of the plane. 你知道那个平面的，这我们那个 homework 会教你。你把这平面侦测到的时候，你就有平面相对摄影机的 R 跟 T， you have the relationship between the plane, this plane here, plane coordinate, and the camera coordinate, and you have an R and T, and you put the object attached to the plane based on the R and T, and then you can find this one. So homework, I'll teach you how to do this one. This is a kind of the AR. We'll continue. So this is the purpose. If you have this one, you recover intrinsic parameters. That's for camera calibration, and you can have a 3D information, and you detect the rotation translation or simulate the rotation translation, and you have a 3D world, a 3D object in the world. So how can we solve those parameters? The same, the entire class, when we teach the deep learning, we will solve the parameters of the weight W and weight B. 我们在教深度学习会教你解决 W 跟 B 的问题，就是深度学习 W 跟 B. So basically, okay. If you the basic model we say the Gaussian model, and Gaussian model has two parameters. One is the mu is the average value. The other is standard deviation. So that's the model. The model we try to solve the average value, try to solve the standard deviation. And that's if you solve this one, and you can have a Gaussian model to model the distribution you want to have. So the purpose for entire deep learning or computer vision, what we try to solve is solve the loss function, the parameters. But this is not easy to solve. So how can we solve the parameters? We will use we call homogeneous matrix. So entire lecture, I will teach you the homogeneous matrix. And what's the homogeneous matrix? Is this one. So we call it's a B equal to AX problems. B equal to AX problems. What's X? X is input. What's B? B is output. So X is an input. Input is meaning you know. You collect the data. You already know the data. So this no. What's output? Output is unknown. Or output some, but if you do the labeling, and you will know. Why we need to do the labeling? That's supervised learning. We will teach you about that one. So most time you know the B, you know the X, you know input, you know the output. Output is mean you predict, you hope. Sorry, not predict. You hope, you estimate, you want to reach the goal. 你要把那物体重建起来，你就是希望做那个物体，或你收集那个 label。所以 this is input, this output. You know, given X, you labeling to be the B, and you can solve the A. So A we call homogeneous matrix. And in this lecture, okay, I will teach you several methods to solve the homogeneous matrix. And this process we call optimization. This process to solve the A matrix, homogeneous matrix, this method we call optimization process. 这叫最佳化处理。Okay, but 我们不玩数学，我们往 vision 这边，我们属于应用科学。We are application guys. Okay, so application engineering. So we just put into the optimization method to solve that. One optimization method is the gradient descent. But gradient descent is not the best method, and we will talk about that one later. Okay, 那个不要玩手机哦，这样干嘛？不要养成习惯玩手机。But for this one, this is not A equal to B problems. They have two matrices. Okay, so this is not B equal to AX, no. This is only one term. So you combine both terms together to be one term. So this is called homogeneous matrix. This is not homogeneous matrix. That means after you solve this one, you can keep solving the intrinsic and extrinsic parameters. So we'll explain this one in the next lecture. So back to the 3D and 2D things. So this is a world coordinate, the object. And we based on RT, and we transfer to the camera coordinate. We project based on intrinsic parameters. We project to the 2D image coordinate, and this coordinate has no distortion, has no camera distortion. Okay, what's the camera distortion? Is this one. This is camera distortion. This is what you see because the lens problems. 那个镜片的关系 lens problems. So we have a camera distortion. Any camera has, the lens of camera has distortion problems. So we want it because this is suppose this is straight line. But it's not equal to, this is not straight line. So we need to recover and distort this one to be straight line. 这是可以做到的，这个很重要。The camera distortion. So what you see is here. So this is a real image you see. So this one is we call distorted image. 这已经变形的 image. So from here, between this one, the distorted image and undistorted image, we need to find the distortion parameters is here. So there are two kinds of distortion parameters. One we call the radial, 就是那种刚看的弧形那种圆形的 distortion. The other is tangential. Tangential 是那种就是正方形会变梯形，会变梯形。这我们后面会下一个章节会讲。就本来是你的是长方形，对不起，长方形会变梯形，就倾斜。那这两个总共有 there are total 5 parameters about distortion. We call K1, K2, K3, and P1, P2. Okay, so we try to find the parameters of this one. So this is D. So back to here, the entire one. So our parameters is from 3D. After intrinsic parameters become 2D image. So this will be your estimation result. 这估计值。This is ground truth. What's the ground truth? So if we use the chessboard, 那个校正板 chessboard, the corner points is meaning you know, given or you detect the corner points. That's ground truth here. So this one become we call summation square difference. Sum of square difference problems. We call SSD problem. So entire lecture, no matter is computer vision, machine learning, or deep learning, we'll keep talking about solving these problems using optimization process. Okay, so this is called loss function. Or loss function. So this again, this is a known. Known is meaning you labeling or you detect already known. So in this case, this is the corner of chessboard. So it detect the corner points. So you know this one. So suppose the 100 point here. Okay. And then you take the image, take the photo. So this is this one. So this estimation is from 3D. After, because chessboard you'll do like this one. Move the chessboard. I'll show you again. So the corner points you detect. Okay. But you want to recover this board to 3D, this 3D. You want to recover this one. So the 3D project to this one is estimation result. So when you solve the intrinsic parameters, extrinsic parameters, you can recover 3D. The camera is here. And this chessboard is here. Okay, so this is from 2D images. You try to recover 3D object. The object is a chessboard. 这是可以恢复回来。所以意思是说什么？意思是说你只要给我一张照片，我很有可能可以，大部分都有办法估计你拍摄的位置在哪里。If you give me one image, just give me one image. It's very possible. I can estimate, I can predict the position, the 3D location. You take the photo using the camera. That's mean the camera position. Okay. I say again. If I take any photo, I can estimate your camera location in 3D. That's meaning where the position you are and take the photo. 这是可以估出来的，这样子。所以从3D 跟2D 的关系，那我们刚刚讲的，什么叫摄影机位置？摄影机位置就是你拍摄的那个位置，你站在那边拍的那个摄影机位置是可以估出来的。So based on this equation, we can solve this. The P prime become to AX. And A is all the 12 parameters. From A, we can recover rotation matrix, intrinsic parameters. Okay, so entire process is here. From 3D to 2D, this is what you see. From 2D, you can reconstruct to 3D. This is what we try to teach you about from the camera model and the camera calibration. In page 47, there's we call Euler angles. Other page you can read by yourself. Okay. Just point out the important part. The Euler angle is important. What's the Euler angle? Original here, you find the parameters, rotation x, the 3 parameters, rotation y, rotation z. But that's the parameters. It's just a real number. 它只是一些整数系数而已。它不是 angle， 所以这个可以转换成 angle 就实际的角度。这个不是角度，这是一些数字。那这个可以再转成角度。那角度我们就称为尤拉角。So suppose this one. So this is a z, right? This is z, and this x is y. So this one. So usually z is there. Z, this camera z, and x and y. Sorry, x x y， so 右手电是 x y z right， so the x is y. Okay, so what's the Euler angle? First of all, okay, if we rotate the z, that's meaning you rotate this one, so our head will become this one. This one we call low rotation, also called in-plane rotation. 这个是这样子，这个这样子，在同个平面旋转。The in-plane rotation we call low rotation， 就这样子 ，low rotation， 同个平面叫 in-plane rotation。We have a two out-of-plane rotation. What's out of plane? Is that at the same plane? It's the same plane. 同个平面，在同个平面上旋转。So out of plane rotation, one is a pitch this way. 像投手投球没有？投手投球，从上面投球下来是 pitch， 这样子。那 why we call out of plane? Because it's not parallel to the camera. It's not the same plane, the same parallel plane. So when the object close to you will become bigger. When the object far away from you will become smaller. OK， 所以它变成一个梯形，这个变成一个梯形，所以是点头。This called pitch rotation or tilt. So this out of plane rotation. 点头 pitch. The other one is the yaw, this one. 所以就摇头，不是在同个平面，这样不是在同个平面上。我们讲平面是摄影机的 XY 平面，那这个已经歪掉了，所以这个会变成另外一个梯形，距离越近就越大嘛，会变形。那所以有这种变形 X 那种变形的作用叫 out of plane rotation， 这个。会扣右，所以如果是在那个飞机，你在飞那个飞机有 pitch， 那个后面那个机翼，最后机翼那边它有 pitch， 你要左右偏嘛，所以机翼还有一个上下嘛，你要上下，飞机要上下这样飞，下面那个，我以前飞弹部队有啊，那个控制那个飞弹，控制飞弹摆。好 ，so the important one is that the Euler angle has two. One is the in-plane rotation, the other out of plane. 那 out plane 没有这种，没有 in of plane， 没有这种东西哦，是 in-plane rotation 跟 out of plane rotation. Okay. So for the Rx 对 x 轴旋转的话，就这个，你对 x 轴旋转 ，x 轴在这里嘛，旋转。它参数在这里，这是 y、z， 是 y 轴跟 z 轴，所以你对 x 轴旋转的话是你对 x 轴x 轴不动嘛，你对 x 轴旋是 y 跟 z 在动，也是这里，那你的角度是 omega， 这是你的角度 phi 跟 k 嘛，那 y 轴旋转是 y 本身不动，是你的 x 轴跟 z 轴在动，是 phi。然后再是 k 小 k， 这三个你要大家了解。所以我们刚刚讲的 out plane sorry the electricity parameter has rx, ry, rz, right? 9 parameters, but that's not angle. So we need to have a function. 我不推导那市场，那个式子可以推导的，在那个 OpenCV 有，你可以把那个 function 变成角度，那就是这个角度。这三个角度，这才是我们要的角度。好，那我们继续。Now next one I will teach you I will teach you about the homogeneous matrix. See on page Here. Okay. I'll teach you about the page 83. Homogeneous. Okay. So before we talk about homogeneous, I will use some examples. Right. So example is here. Page 51. Page 51. Okay. So before we talk about why we need a homogeneous matrix, because we try to solve the parameters, okay, using optimization process. So one example is one. So suppose in 3D, one point here, px, suppose is this only in the plane. Okay, 这是一个假设一个平面，一个剖面哈，剖面一个平面。So xz, so this is z, right? Xz plane and this x. So in the xz plane, you have one point here, project on here, and you put this is camera coordinate. 这摄影机在这里 and this is your image plane. So you project to here, there's one image point is small x, and image planes, the z-axis of image, the z distance of image plane to the camera coordinate is f. 焦距，影像一定是在那个摄影机坐标的 f 那个焦距上。So this is f. So in this one, in 3D, so 3D is x compared with z equal to the image plane x, small x, compared with the focal length. And this you know. This you unknown because in image plane you can see it's only this one. 在影像上，你看到物体都是在影像上看到的，所以这个 f 是你可以去那个 calibrate 出来，或是你已经知道的。So x equal to this one. The same in the YZ plane, y equal to this one. 用相似三角形方式呢 ，the similarity of triangular。那这样的话，你的最后变成这个嘛 ？In 3D will become this one, because this point is x y. The coordinate of P in image plane is x y. You have focal length f. And you doesn't know the 3D position x, capital X, capital Y, capital Z. So can you do the home? We try to solve. Let's say again. In this one, in this one, what you know is x, y, because you can detect the P in image plane. Right? You try to estimate or you try to recover or reconstruct the 3D point x, y, z. And suppose you don't know f. You try to solve the intrinsic parameters of focal length f. How can you solve it? So here is a homogeneous matrix. How do you create the homogeneous matrix? So that's meaning, how do you write a program, write a code to solve it? 你在写程式的时候，刚刚讲的，你要写程式的时候是要写成这个形式。So when you do the programming, you do the coding. It's a vector or matrix. It's not an equation. If you write a code, it's using equation method. Okay, so right now, suppose you have 4 points. 4 points, right? 1 point is x, y, so 2 equations. 4 point, you have 8 equations. But when I am user, if I detect 6 points and your code doesn't work, that's the problems. So how can you write a code and then allow the user, no matter how many points it get, you still can run it, can process it. You cannot use equations. Equation 就限制住了嘛，你不能用 equation 来做，你只能用 vector 跟 matrix 方式来写，那就是 homogeneous matrix 要叫你做的。So how can we create a homogeneous matrix? This one. So you know you already have an input x, y, z, like a chessboard, right? So and your image is x, y. So homogeneous matrix is first of all, you need to have a scaling term here, a scaling factor. 你要多一个 scaling term 在这里。所以它答案是 x prime, y prime 跟你要先写这个，你要一个 scaling term 先写。So for the homogeneous matrix process, you have 2 steps. This is your original equation. 你原来equation 是这样子哦 ，equation 1, equation 2。那你如果有2个点，就变成这一个点有 x, y 坐标嘛，就2个 equation， 2个点就有4个 equation。那我们以这个点来讲的话 ，OK， 你有影像坐标 x, y， 但是你要写 homogeneous matrix 是这个变成2个步骤。第一个步骤就是这个 x prime, y prime, w prime, and your value. This one is after you have this one, okay, and the result is this one, x, y. So x prime divided by scaling term w prime become your final result. Y prime divided by w prime become your final result. 那this one I will for the exam probably I will ask you to give you this one, and I will ask you try to write what's its homogeneous matrix. The answer is here. My exams always try to that you try to understand the physical meaning or simple way, not difficult way. This concept. So I give you this one and ask you to write the homogeneous matrix. The answer is this one. Okay, so back to here. So this one you need to have 2 steps. The final step is from here. The final answer is x prime will divided by scaling term w prime. Y prime will divided by scaling term w prime. So this is your final answer here. And your homogeneous matrix is this one. This one, so based on this one, you will see this one, S prime here. S prime is a nominator term, 是分子的 term. 分子，那分子有什么？分子是 F 跟 X， 那 X 是 input， 所以 X prime equal to this line。So X is nominator term. What's the nominator term is that this one is input X, right? 你这一行要乘上这一行 ，X 等于这一行 times this one， 所以 Fx so F here and the 0, 0, 0. So this one is this one nominator term. Y the same. Y prime equal to Fy. So it'll be 0, right? This row times this column. So F will be here times Y. What's scaling term? Because scaling term, this one is a denominator term, 是分母的 term. 分母的 term. 那分母是什么？分母是 z 嘛？分母是 z. So this term equal to 1, 2, 3, the 3 times z. So this one, this line times this line. Okay, so this will be your homogeneous matrix. So given trace-board here and you image here, you can try to solve this one. Okay, so that's one example for your homogeneous. 那个讲义的内容你们自己再看一下，有需要你们再看哦。那我直接跳到后面这边。刚讲84页这边，不是，错了。这另外 ，this is the other example。那你自己看，这个你自己看 the other example about homogeneous matrix. This one, the three equations, and how can I write to the homogeneous format? Okay. So I'm page 84 here. I'm sorry, 83. Page 83. 时间到。What we try to say is from here. I want to say is here. Any point in your, no matter 2D or 3D, any point, any data is 1 point, so it's a sample. 这我昨天晚上有改啊，我把新讲义放上去，这边我有改一些东西哈，都会 update. So any point, when you write a data, you collect data, a point. The point is actually a sample. Sample is a vector. Because we talk about homogeneous matrix, homogeneous matrix considered is a vector, right? And a matrix. So we try to solve the matrix A. So what's the vector meaning? What's the X and B? What's the meaning for X and the B? I will try to explain to you. 那这边我希望你开始要你研究生一个 graduate student, you or you are like a senior student. Okay. I want you to have the other way to think about something. So I will explain like this one. So any point is one sample. So point meaning what? In the space is a vector. So all the mathematics either is a vector or matrix. So right now I want to teach you is to think about not only point, you think about the vector, the matrix. 我开始要教你是你要从用 vector 跟 matrix 观念来想事情这样子。OK， 那我们下课10分钟，我们待会再继续讲这些观念问题，就这2个问题。谢谢。